Hello, let's continue our Sudoku adventure with Battleship Doubleprise by Wuschel. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have doublers. If you remember our doublers week, this was left over from that. So let's say this, but there's 6 doublers hidden in the grid. We don't know where they are. We have to figure that out as part of the logic of the solve. But let's say this ends up a doubler. Well, first of all, every row, every column, and every box has exactly one doubler. So the rest of its row, the rest of its column, the rest of this box will not be a doubler. Let's make that gray to represent that. But what does a doubler actually do? Well, it doubles the value of the digit in its cell. So the digit is 2, the value will be 4 on doublers. The only other thing to know about doublers is that each digit is doubled exactly once. So we cannot double the 2 twice like this. This would not be allowed. We could double the 1 and the 2, for example, but not the 2 twice. Each digit ends up doubled exactly once. Now, what does that mean for the value to be doubled? Well, we have killer cages in the grid. So some of these cells are surrounded by dotted lines. Those are called cages. First of all, digits can't repeat in a cage. That means I can't put another 2 in this cage somewhere, even if Sudoku rules would have allowed that. So like I can't put a 3 here and a 3 here within this same cage. That's not going to be allowed. But what I could do is I could put a doubled 2 and a 4. The values are allowed to repeat, but the digits are not. And so the values of the cells add up to the clue in the top left, which is 12 in this case. So we need to make these add to 12. This counts as 4. I could put another 4 in there. This would be 8 now. And then 8 plus 4, so we could do 1 and 3. So this would add to 12. Because the values add to 12, because this one's doubled. Hopefully that makes sense. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. And I'm definitely going to start with this 17 cage, because that's huge. The biggest natural cage would be 11, 5 plus 6. But this is 17. The difference there is 6, which means we need a doubled 6 in it. So we know it has a doubler, first of all, and we know the doubler is the 6. I will use this corner marked 6 to remember that 6 has been doubled. No, and now none of these can be doubled, no matter where this 6 ends up. We don't know which column it's in, but we know the row and we know the box. 14 is still too big, so that definitely has a doubler in it, so that's not doubled. Now we need to put a 5 and a 6 down here, just for the box logic. So they can't both go in here. Because if I have a 5, 6 here, I need to double the 5 at that point, and that would be 16, not 14. So one of them is going to go over here in this 12 cage. So let's think about the cases here. There's one case where there's a 5 in here, and the 5 is doubled. Because we can't put the 6 in here and double the 6. We can put the 5 here and double the 5. So let's think about that case. There would be a doubled 5 with a 4. That's one case. If we put a 6 in here, or we could put a 5 in here without doubling it, but does that actually work? We need 9 more. No, that doesn't work. Because if we don't double the 5, then we have to double the other digit, which will be even after doubling it, and then that'll be an odd number. Even plus odd is odd. Basically, we'd have to double a 4.5. That's not going to work. So if there's a 5 over here, it's doubled with a 4. Now, otherwise, there's a 5 or a 6 in here with a different value being doubled. Again, it can't be the 5. So otherwise, there's a natural 6 in here with a doubled 4. Okay, so this is 4, 5, 6 no matter what. And it definitely has a 4 in it. But we don't know if it's a 4 with a doubled 5 or a 6 with a doubled 4. So this is a 4, though. All right, this is looking pretty big. The minimum this could add to is 9. So the max these can add to is 3, and that is also the minimum they can add to without any doublers. So that has to be a 5. Okay, so that ends up a 4, 6 with a doubled 4 in it. I probably shouldn't have cornered the 4 because I was using that to determine what was doubled, but that worked out because the 4 is doubled. There's nothing really to mark there. All right, so we can mark that this is 1, 2, 3, and then this is also 1, 2, 3. All right, I think I want to look at this column because this 18 cage, we know 3 of the digits in it. It's got a 3, a 5, and a 6 in it. Now, one of these will end up doubled, and it'll be the 5 or the 3, because the 6 is already doubled. So let's think about that. 3, 5, 6 naturally adds to 14. So if I were to double the 5, we'd get to 24. So we're not doing that. We're doubling the 3. So there's a doubler in here, and it's the 3 being doubled. So that's 6 plus 11. That's 17. So we need a non-doubled 1 to go with that. Nice. Okay. 12 is still too big. I probably should have realized that. But I was looking at this. 12 is still too big. So there's a doubler in here, which does make this not a doubler, and it makes it not a 3. So how are we getting to 12? I guess the first question to ask is, do we have to double the 5 to get to 12? If otherwise we're doubling the 3. No, we have the 3, 4, and 6 doubled. So if we're not doubling the 5, we're doubling a 2. That's not big enough because we have to exceed. We have to do at least 6 plus 6, right? So we can't double the 3, we can't double the 4, can't double the 6. Yeah, okay. So we're doubling a 5 in here. And that's going to go with a 2, just by math. And so that's a 6. So one of these is doubled. Okay, these are not doubled. These are not doubled. 4 cage? Well, we know there's a 1 in it, for sure. So it could just be a 1 plus 3 naturally. That would put the 5 here. No, that actually there can't be a 3. This is only from 125. Oh, this is 125, so that's not a 3. That's a 5. Okay, that's easier. That's the doubled 3. So this is 1 and 2. To get to 4, we have to double the 1. We know there's a doubler in here anyway, so that's good. So this is 1, 2, 3, 4, and 6. This is 3 and 4. Okay. So we've doubled. Right. There's one more doubler. This column needs it. It goes exactly here. And it's a 2. That's the last digit that can be doubled. So that gets us some digits. This is 4, 6. So none of the rest of the puzzle is doubled. So these HK cages are au natural. Okay. What are we doing then? I guess we're thinking about 8 cage. Well, an 8 cage that isn't doubled doesn't have a 4 in it. So that's a 4 and a 3. It's the only place for 4 in the column. That's 1 and 3. So now this doesn't have a 3 in it. Oh, we can do 2 and 1. This doesn't have a 3 in it, so it's not 3, 5, so it's 2, 6. So that's a 6, that's a 2, that's a 5, that's a 6. So this 6 is doubled. And the 1 is doubled. That's working out. Okay. So this does add to 4. This does add to 17. Good. These are just 4 and 5. All right, can we do something similar with this 8 cage? It doesn't have a 2 in it, so it has to be 3, 5. We know the order. So that's 2 and 5. The 5 was doubled here. So that means this is not doubled and this is doubled. The doubled in here was a 4. Yep, 1 and 2, 4 and 5, 6, 4, 3, 6, and then a 1 and a 4 here, and we're done with the correct solution. Nice. All right, cool. That was a nice doubler puzzle, Wuschel. Yeah, I enjoyed the sort of paring down of which digit can still be doubled. It feels a little bit similar to my idea, but that's fine. I enjoyed my puzzle too. So I think this was a good demonstration of doublers and how they work. I liked the logic of forcing these cages. Like the sums were very well picked for these. And we didn't know what was doubled in the 12 cage until we actually figured out that 3 was doubled in this column. So that was neat. I hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.